Okay, let's unpack this. If you've been following the world of I mean, the buzz around large language models, LLMs, it's been constant.
Absolutely relentless.
But there's this new, even more advanced concept really gaining traction. AI agents. And these aren't just your average chatbots. They seem to represent a pretty significant leap in how we think about AI's capabilities.
Exactly. Yeah, when we talk about an AI agent in this context, we're really moving beyond those simpler LLM apps or traditional predefined workflows.
Okay, so define workflow versus agent for us then.
Right. So think of a classic workflow like a meticulously choreographed dance. The LLMs and tools, they execute very specific steps along fixed pre-coded paths. Someone designed that flow explicitly.
Got it. Scripted.
Totally scripted. An agent, though, is more like a jazz improviser. The LLM itself is dynamically directing its own process. It decides which tools to use, when to use them, and it maintains control over how it actually accomplishes a task. It's a fundamental shift, really, towards greater autonomy.
And the world of AI agents is it's moving so incredibly fast, it feels easy to get lost in the hype sometimes.
Oh, absolutely.
So our goal today is to, cut through that noise together, to really understand the fundamental principles and maybe some of the surprising paradoxes even that guide building these powerful systems.
Yeah, paradoxes is a good word for it sometimes.
We hope this deep dive offers you a kind of shortcut, helps you get well informed on building these new kinds of systems.
Sounds good.
So to kick things off, I think one fundamental question we need to tackle is, when should you even consider building an agent?
Right.
You might be thinking, okay, this sounds great, agents, autonomy, but when do you actually need one versus, just over-engineering things?
That's a critical question.
Let's tackle that right now.
Yeah, it's a brilliant starting point because, honestly, for many, many applications, just optimizing your single LLM calls, maybe with good retrieval, some good in-context examples, that's usually more than enough. And Anthropic's advice here is really crucial. Always find the simplest solution possible first. Only increase complexity when it's absolutely necessary.
That's not just about cost, right?
No, absolutely not. An ill-suited agent can introduce just a cascading nightmare of bugs, unpredictable behavior. The real insight here, I think, is in AI, complexity isn't some badge of honor.
Right.
It's really a debt you pay in latency, in cost, and definitely in maintenance headaches down the line.
That's a really important framing. Complexity as debt. So if it's a debt, when is that added complexity warranted? When do agents actually earn their keep?
Well, both Anthropic and OpenAI, they tend to agree on a few key scenarios where agents really shine.
Okay.
One is when you need genuine flexibility and model-driven decision-making, but at scale.
So not just one-off decisions.
Exactly. This includes complex decision-making that involves nuanced judgment or handling lots of exceptions or maybe highly context-sensitive decisions. Think about deciding whether a complex customer service refund gets approved.
Lots of variables there.
Tons. They also excel, where you have rules that are just difficult to maintain. Imagine a traditional system becoming completely unwieldy because it has these intricate rule sets for, vendor security reviews or something.
Yeah, those can get crazy.
Right. An agent might handle that more dynamically. Another big one, heavy reliance on unstructured data.
Okay. Like text?
Exactly. Where the agent has to interpret natural language, extract meaning from documents, manage rich conversational interactions. Think about processing a really convoluted home insurance claim from emails and phone call transcripts.
Right. Messy data.
Super messy. And finally, agents are great for open-ended problems. The kind where it's difficult, maybe even impossible, to predict ahead of time how many steps are going to be required to actually finish the task.
Okay, so we've kind of established the why you might need an agent for certain tough problems. Now, let's say you've decided, okay, an agent is the way to go. What are the fundamental, the Lego bricks you're snapping together to build this thing?
So the foundational element is what we often call an augmented LLM.
Augmented LLM.
Okay. And it's not just about having a powerful model. Think of it like giving a brilliant mind some external senses and limbs.
Yeah, okay. Like superpowers.
Kind of. So retrieval means it can instantly pull specific facts from vast databases, like having a super fast research assistant built in.
Okay.
Tools are its ability to actually act on the world. Querying APIs, sending emails, updating a CRM record, basically giving it a keyboard and a mouse, metaphorically speaking.
Right, taking action.
Exactly. And memory allows it to remember past interactions. That provides crucial context across a potentially long task, much like a human's evolving understanding during a conversation.
So the augmented LLM is the core intelligence plus these capabilities. And OpenAI, they break down the agent's operational core into three main components: the model, tools, and instructions. Let's start with the model. That's the brain, right?
Precisely. The model is, of course, the LLM itself. That's what powers all the reasoning, the decision-making. But here's a really crucial insight for anyone building these. Not every single task within an agent needs the smartest, most expensive model available.
Ah, interesting. So you can mix and match.
Yeah, a savvy strategy is often to prototype your agent using, the most capable model you can get, like a GPT-4 or a Claude 3 Opus. Establish a performance baseline. Know it can work.
Okay.
Then, once you know it works, you can start strategically swapping in smaller, faster, cheaper models, maybe a Haiku or a GPT 3.5 for specific subtasks, and see if they still achieve acceptable results.
Right. Optimize for cost and latency.
Exactly. Optimize for cost and latency without prematurely limiting the agent's overall potential capabilities.
Okay, so if the model is the brain doing the reasoning, even the smartest brain needs a way to act, like you said. That's where tools come in, I guess.
Exactly. Think of tools as the agent's hands and feet. It's the ability to actually do things beyond just thinking or talking. They are basically external functions or APIs that the agents use to take action in the real world, or even digital systems. Querying databases, sending those emails, updating CRM records, searching the web.
Or practical stuff.
The practical stuff. The key here, though, is standardization. You want standardized definitions for these tools. Make sure they're well documented, thoroughly tested, and ideally reusable across different parts of your system or even different agents.
And OpenAI categorizes them.
Yeah, they talk about data tools, which are mostly for retrieving context, action tools for interacting with external systems, and interestingly, even orchestration tools, where one agent can actually serve as a tool for another agent.
Whoa, okay. Agents calling agents.
It gets meta.
Huh. And finally, rounding out these core components, we have instructions. These sound like the agent's internal rulebook or guidelines.
They are, essentially. Instructions are the explicit guidelines and, importantly, the guardrails that define how the agent should behave.
How do you make those effective?
Well, best practices include things like leveraging existing documents.
Yeah.
You might already have like standard operating procedures or support scripts to create LLM-friendly routines. It's also really vital to prompt the agent itself to break down complex tasks into smaller, clearer steps.
Ah. Get the agent to help define its own process.
Exactly. Define clear actions for each step and try to proactively capture edge cases in those instructions. This really helps reduce ambiguity and helps the agent make better, more predictable decisions.
That makes perfect sense for defining the intended behavior. But what if, say, a clever user tries a jailbreak? Tries to trick the agent into ignoring those instructions. How robust are these guidelines against that sort of thing?
That's a critical point, and it really highlights why guardrails, which we should definitely talk more about later, become this multi-layered defense. Instructions provide the intended path, but you absolutely need to complement them with robust safety classifiers, input validation systems, things that catch malicious or just weird out-of-scope inputs before they can manipulate the agent's core logic based on those instructions.
So it's an ongoing battle.
It really is. It's a cat and mouse game, constantly evolving. But well-designed instruction sets are absolutely your first line of defense.
Okay, so we have the building blocks, augmented LLM, model, tools, instructions. Now, how do you actually put them together effectively? This is where I think the concept of workflows comes in, these practical patterns for building agentic systems.
Exactly. And Anthropic outlines several really common workflow patterns. They're essentially like recipes for combining these elements.
Okay, give us some examples.
Sure. First, there's prompt chaining. This is pretty straightforward. It involves decomposing a task into sequential LLM calls. The output of one call becomes the input for the next one.
Like an assembly line.
Pretty much. Yeah. Imagine generating some marketing copy, then immediately passing that text to another LLM call to translate it into Spanish. Yeah. Or outlining a document in one step and then having a subsequent call write the full document based on that outline. It's really ideal for tasks that you can easily break down into fixed, ordered subtasks.
Makes sense. What else?
Beyond just sequential, there's routing.
Routing, okay.
This directs different categories of input to entirely separate processes.
Yeah.
Or maybe different models. Think about customer service again. General questions might go one way, refund requests another, complex technical support issues a third way.
So different paths for different needs.
Exactly. Or you can even route based on difficulty. Maybe easy questions go to a smaller, faster, cheaper model like Claude 3.5 Haiku, while the harder, more nuanced questions get routed to a more capable, maybe slower, more expensive one like Sonnet. You optimize for cost and speed across the whole system that way.
Clever. What about doing things at the same time? Parallelization. That sounds like the efficiency dream.
It absolutely can be. Yeah, parallelization lets LLMs work simultaneously on different subtasks, and then their outputs get aggregated programmatically somehow.
How does that work?
Well, there are two main variations Anthropic mentions. One is sectioning. That's where a task is broken down into independent subtasks that can genuinely be run in parallel. Like maybe one LLM is screening user input for inappropriate content, while another LLM is simultaneously processing the user's actual query.
Ah, okay. Working side by side.
Right. And then there's voting. This is where you might have multiple prompts or even multiple model calls review the same thing, perhaps reviewing a piece of code for potential vulnerabilities from different angles, or maybe evaluating if content is harmful, with various prompts offering different perspectives to arrive at a more robust kind of ensemble decision.
Interesting. Okay, I love the name for this next pattern. Orchestrator workers. That just sounds powerful.
It is pretty powerful. In the orchestrator workers workflow, you have a central LLM, the orchestrator, that dynamically breaks down larger complex tasks. It then delegates these subtasks to specialized worker LLMs, and finally, it synthesizes all the results back together.
So the orchestrator is like the project manager.
Exactly like a project manager. And this is incredibly useful for those complex, open-ended tasks, as we mentioned earlier, where you can't really predict the exact number or nature of subtasks up front.
Any examples?
Yeah, think of maybe a sophisticated coding assistant making complex changes across multiple files in a large code base, or complex research tasks that need to gather information from a whole variety of web sources and then compile it into a single report.
Got it. And the last pattern?
The last one they highlight is Evaluator Optimizer. This one really feels like a loop, like the agent is constantly improving itself.
How so?
Well, it typically involves one LLM generating a response or a piece of work, and then another LLM providing evaluation and feedback on that work. This happens in a loop, iteratively refining the output.
Ah, like critique and revision.
Exactly. It's very much like a human writer's iterative process, right? You draft something, you get feedback, maybe from an editor or another LLM in this case, and then you revise. It's highly effective for tasks where nuance is critical, like maybe literary translation or, again, those complex research tasks that might require multiple rounds of searching and analysis to get truly comprehensive information.
Fascinating patterns. Okay, now, here's where it gets really interesting, I think.
Uh-oh.
Because we're about to dive into a critical and, yeah, somewhat debated area, multi-agent systems.
Ah, yes. The debate.
You see these two recent blog posts, right? With seemingly contradictory titles. One's like, Don't Build Multi-Agents by Walden Yan, and the other is How We Built Our Multi-Agent Research System from Anthropic. What on earth is going on here? Are they fighting?
Not exactly fighting, but it's a fantastic example of the nuanced discussions happening right now.
Yeah.
So Walden Yan's core critique of multi-agent architectures is essentially that they can be incredibly fragile.
Fragile.
He uses this really vivid example. Imagine trying to build a clone of the game Flappy Bird using two sub-agents. One agent builds the background, the other builds the bird character.
Okay.
If they don't share context properly, if they aren't perfectly aligned on the overall goal and style, you might end up with, say, a Super Mario Bros. Style background and a Flappy Bird that looks completely out of place. It just doesn't work together.
Right. Visual clash.
Exactly. This miscommunication, or what he calls conflicting decisions, leads to poor results because that crucial context isn't fully shared between the agents. Every action an agent takes carries implicit decisions about the overall project.
So what does Yan propose?
He lays out two key principles based on this. First, share context. Share the full agent traces, the whole history, not just the last message between agents. Second, understand that actions carry implicit decisions, and conflicting decisions between agents lead to bad results.
Okay, so share everything, be consistent.
Pretty much. And based on that, he suggests that a single-threaded linear agent, just one agent working step by step, is often the simplest and most reliable way to follow these principles.
But what about really long tasks? Doesn't the context window become an issue?
He acknowledges that, yeah. For very long duration tasks, the context window is a real limitation. His proposed solution for that is quite clever. Use another LLM, maybe a specialized one, whose main job is to compress the long history of actions, conversations, and decisions down into just the essential details. Basically, summarizing the story so far for the next step, keeping the context manageable.
Interesting. Okay, that Flappy Bird example really does paint a picture. It reminds me of trying to co-edit a document without seeing real-time changes, just chaos.
Exactly that kind of chaos.
So that's the don't build them or be very careful side. What about Anthropic's perspective? LangChain highlighted their work. How are they making multi-agent systems work, apparently successfully?
Right, so Anthropic, viewed through LangChain's analysis, successfully uses patterns like that manager pattern. We discussed a central LLM orchestrating specialized worker agents via tool calls.
The orchestrator worker model again.
Exactly, and also a decentralized pattern where agents might hand off tasks to one another sequentially, which they say is common for things like triage systems.
Okay.
But the key insight, the thing that kind of bridges these seemingly opposing views, comes from LangChain's observation. Multi-agent systems that primarily read information are significantly easier to build and manage than those that need to write or modify things concurrently.
Huh. Why is that distinction so important? Reading versus writing.
It really boils down to managing conflicts. Read actions like gathering information from different sources are inherently more parallelizable. If two agents are reading different parts of a website or different documents, there's usually no conflict.
Right, they don't interfere.
Exactly. But when you try to parallelize writing actions, like having multiple agents trying to write code in the same file or contribute to the same report simultaneously, their actions, their implicit decisions, can easily conflict. This can produce incompatible outputs that are extremely difficult, sometimes impossible, to reconcile nicely.
Like trying to have two people type in the same sentence at once.
Precisely. Conflicting write actions typically produce far worse, more chaotic outcomes than conflicting read actions, and Anthropic's own Claude research system is a perfect example.
How so?
Their multi-agent architecture apparently handles the research phase, the reading part, gathering info from lots of different places. But the actual writing, synthesizing all those findings into a single coherent report that's deliberately handled by a single main agent, often in one unified call. They do that specifically to avoid the complexity and potential chaos of multiple agents trying to write together.
That makes a lot of sense. Avoid the writing conflicts.
Yeah, control the writing.
So, despite these headlines that sound like they're disagreeing, there's actually this crucial common ground they both seem to share. It's less about if you build multi-agent and more about how you manage the information flow, the context.
Exactly. The universal agreement, the bedrock principle here, is that context engineering is critical.
Context engineering, beyond prompt engineering.
Yes, it's like the next level. Whether you're trying to prevent your Flappy Bird from looking like Super Mario or ensuring your research agent writes a coherent final report, the fundamental challenge is managing that shared understanding, that dynamic context.
Okay.
It's not just about crafting the perfect initial prompt anymore. It's about automatically, intelligently managing the entire conversation's memory, the state, the history, especially in these complex, long-running systems.
And how do they do that? How does Anthropic manage context in their system?
Well, they talk about using intelligent compression and memory mechanisms.
Yeah.
This could mean having agents periodically summarize completed phases of work and storing those summaries, maybe in an external vector database or something.
Okay, creating checkpoints.
Kind of like checkpoints, yeah. Or maybe even spawning fresh subagents for specific tasks, giving them only the clean, necessary context through a careful handoff. This maintains continuity without completely overwhelming the main agent's context window.
So what does this all mean then? For you, the learner, the builder, looking at this debate, should you or shouldn't you build multi-agencies?
Well, it means that while multi-agent systems definitely have these challenges, particularly around writing and context sharing, they can still excel. They can be really good for breadth-first exploration, pursuing multiple independent lines of inquiry simultaneously.
Like the research example.
Exactly. They're also potentially effective when the sheer volume of information you need to process exceeds the limits of a single model's context window. And critically, they make the most sense when the value of the task you're trying to accomplish is high enough to justify the increased cost and, frankly, the increased complexity that comes with building and managing such systems. It's a trade-off.
A calculated trade-off. Okay. So building these complex systems, whether they end up being single, long-running agents or multi-agent setups, it definitely sounds like there are some practical engineering challenges to overcome once you move from whiteboard to actual deployment.
Oh, absolutely. There are definitely hurdles.
What should we be aware of?
Okay, a few key areas come to mind. First is durable execution and error handling.
Durable execution.
Yeah, agents are spateful, right? They maintain information, they have memory, and errors in one step can compound and mess up later steps. Plus, these agents can run for a long time, potentially hours, maybe even days for some tasks.
Wow, days.
It's possible for very complex asynchronous tasks. So your system needs to be durable. It needs to be able to potentially resume from precisely where an error occurred, not just restart the whole thing from scratch. Restarting could be incredibly expensive and super frustrating for the user waiting for the result.
Yeah, that makes total sense. Like having to rewrite an entire email if your browser crashes versus just picking up from the last saved draft. What about figuring out what went wrong when it does fail?
That's the second big challenge, debugging and observability. Agents, especially complex ones, make dynamic decisions. And LLMs themselves can be non-deterministic.
Meaning they don't always give the exact same output for the same input.
Exactly. You might feed the same prompt twice and get slightly different reasoning paths, maybe slightly different wording in the output. It's like asking two different equally smart people to solve a problem. They might arrive at the same answer but take different routes.
Okay, so that makes debugging harder than traditional code.
Much harder, because A doesn't always equal B in the same way. So having full production tracing logging every step, every thought process, if the model supports it, every tool call, every decision the agent makes becomes absolutely crucial to diagnose why an agent failed or went off track. You need that visibility.
Got it. Trace everything. And then how do you even know if your agent is actually, good, if it's doing what you want it to do reliably?
That's the third one, evaluation of agents. It's essential, obviously, but it can be surprisingly tricky to do well.
Oh, tricky.
Well, defining success can be complex, especially for open-ended tasks. The advice generally is to start small. Even evaluating on just, say, 20 diverse data points or scenarios can give you initial signal. You can also leverage another LLM as a sort of judge for automated scoring during experiments comparing outputs.
It's LLM as a judge. Okay.
Yeah, it can help scale evaluation. But ultimately, especially for critical applications, human testing and review remain absolutely essential for true validation. There's really no substitute for a human eye catching nuances or subtle failures.
Human oversight is key. Okay, so beyond just performance and debugging, safety and predictability are obviously paramount, especially if agents are taking actions. This is where guardrails come in, right?
Yeah.
To keep the agent from going off the rails.
Exactly. Guardrails are a critical layered defense mechanism. You really need multiple types working together. They're designed to prevent various risks, things like data privacy breaches, users tricking the agent with prompt injections, or even just reputational damage from the agent saying something harmful or off-brand.
So what kinds of layers are we talking about?
There are several common types. You might have a relevance classifier that flags queries that are totally off-topic for the agent's purpose, like asking a customer support agent about, the height of the Empire State Building.
Okay, keep it on task.
Right. Then a safety classifier specifically looks for unsafe inputs, like known jailbreak attempts or prompt injections trying to steal the system prompt.
Oh, malicious stuff.
Exactly. PII filters are crucial to prevent the agent from accidentally exposing personally identifiable information. Moderation APIs can flag generally harmful content like hate speech or harassment.
Standard content moderation.
Yep. Then you have tool safeguards. This is important. Assessing the potential risk of each tool the agent can use, maybe labeling them low, medium, or high risk.
Why categorize the risks?
So you can trigger additional checks or maybe even require human escalation or approval before the agent takes a high-risk action. Things like canceling a large order or authorizing a big refund, you want checks on those.
Makes sense. Any others?
You can also have simpler rules-based protections, like basic block lists for certain words, or maybe just limits on input length. And finally, output validation is important, checking the agent's final response to ensure it aligns with, say, your brand's voice and tone guidelines, or is in the correct format.
Wow, that's a lot of layers.
It has to be, really, for robust safety.
And even with all those automated safeguards, it sounds like human intervention remains critical, like the ultimate safety net.
It truly is. It's pretty much an indispensable safeguard, especially when you're first deploying an agent or when it's handling really sensitive tasks.
Why indispensable?
Because it allows the agent to gracefully hand things over when it gets stuck, when it genuinely can't complete a task, or maybe encounters a totally novel situation it wasn't trained for. This improves the real-world performance and user experience without just having the agent fail outright.
So when would you typically trigger that human handoff?
There are two main triggers usually. One is exceeding some predefined failure threshold. Like if the agent fails to understand the user's intent after, say, 2 or 3 attempts, it might automatically route to a human.
Okay. Stops the frustration loop.
Exactly. And the second trigger is attempting those high-risk actions we just talked about, sensitive or irreversible things like authorizing large refunds or deleting important data. In those cases, requiring human oversight, at least initially, is just prudent risk management until you gain really high confidence in the agent's reliability for those specific actions.
Okay. So after this really comprehensive deep dive, I feel like the main takeaway is pretty clear. There's really no single one-size-fits-all solution for building these AI agents.
Absolutely not.
It seems to be all about starting simple, iterating, and only adding that complexity, whether it's more tools, more elaborate workflows, or even multiple agents only when it demonstrably improves the outcomes you need. And always understanding the trade-offs involved.
Precisely. That's the key message. And while the challenges we've discussed certainly exist, context management, debugging, evaluation, safety, the evolution of these agentic workflows is definitely going to continue reshaping how we interact with and build intelligent systems.
Yeah.
The core principles, though, I think will remain crucial. Aiming for simplicity where possible, transparency in how they work, and really thorough testing and evaluation. That's how we build systems that are not only powerful, but also reliable, safe, and ultimately maintainable in the long run.
So maybe a final thought for you, the listener, to consider, building on that multi-agent discussion. What will it really take for multiple AI agents to collaborate truly effectively, almost like humans do, seamlessly sharing context and intent?
That's a big question.
Will advances in how even single agents communicate better with us, with humans, eventually unlock ways for them to communicate better with each other, achieving greater parallelism and efficiency? What does that future of agent collaboration look like for you? What stands out to you from our discussion today?